Hi, my name is Morgan Rodery, and this is my submission for the IDF forum. So this is over a master's thesis study. My study was over the occupancy of small mammals in Missouri's fragmented prairies. For a little brief intro, so historically prairies extended across most of Missouri. They're now dwindling, and they're often surrounded by agriculture or other developed land, such as housing. This has resulted in a mosaic-like landscape, which is made up of small patches that are isolated from each other, and this has caused these fragmented landscapes. So my first hypothesis was that species occupancy will increase as patch size increases. And my second hypothesis is that prairie patches with a high level of isolation will have lower values of species richness than those patches that are closer to similar habitat. And species richness is just the number of species in a patch. My methods, so my data analysis, I use Google Earth Pro and a program called QGIS to actually delineate the prairies so that you could actually see where they are. QGIS was used to determine relevant conservation areas in designated prairie habitat that was proximal to my sampling sites. I use program R to determine the isolation of prairie patches, so their minimum and mean distances to other similar habitat. I also used R to perform Mantell tests using a Bray-Curtis distance to test the correlation between isolation metrics of each site and species richness of each site. I also used R to compare the area of each site with species richness. As far as my field methods, I sampled 12 prairies from June to July of 2020. I used Sherman live traps baited with sunflower seeds, and trapping stations at each prairie were placed along these 250-meter transects. They were placed at 10-meter intervals using a point transect method, and 2 traps were set at each trapping station. Traps were set in the evening and then checked the following morning. That was just so that the animals in the traps would not get too hot. And the geographic coordinates of the beginning and end points of trap lines were recorded so that this study could be reproduced later. The number of trap nights was recorded for each site every day. Sites that contained 2 trap lines could have a possible 100 trap nights, as a total of 100 traps were set per site. And then mammals that we captured were identified to species level. We took some measurements of them. We took measurements of the right hind foot length, ear length, and tail length, and we also sexed the individuals. We also gave them a unique ear tag with a unique number on it so that we could identify them later in the study. Here you can see this is a figure of our captures. So the gray squares indicate that the species were captured in that site, and white squares indicate that they were not captured in that site. And here the names are our sites and the species that we captured. We found that area of the patches was not correlated with species richness, and the level of isolation of the patches was also not correlated with species richness. So the mechanism that was actually driving the differences in species richness across sites was not found in this study. And the results of this study demonstrate the need for long-term studies of small mammal population trends, as well as for other short-lived animals. It's hard to take kind of a little capture of the abundance while you're doing your study, and we really need more long-term studies to find out what's going on and what is causing the differences in species richness over the sites. The data collected in this study, though, can provide baseline data and the potential for repeatability of data collection at these sites by future researchers. Thank you.